Dear participants, welcome back to the session 8. It gives me a great pleasure to introduce our esteemed speaker for this session, that is Mr. K. Raja sir. He is a dedicated IT professional with over 10 plus years experience in Snowflake and Oracle EBS. He has been awarded as a Customer Service Award for commitment and performance, and also he received a Stellar Award for exceptional work in customer support and consistently surviving for customer delight. Sir has worked as an Oracle Apps senior consultant at Snowflake Technologies, Bangalore, for the period of 5 years. And he worked as a senior technical analyst at Jade Global Software Private Limited for the period of 3 years. And currently, he is working as a senior associate at Cognizent Technology Solutions, Austin, United States of America. Dear all, please join me in welcoming Mr. K. Raja sir. Welcome, sir.
Yeah, good evening. Am I audible?
Yes, sir. Audible, sir.
Yeah. Sorry, sincere apologies for my camera is not working right now. Some issue with the camera.
It's okay, sir. Okay.
Yeah. So, okay. I think we had a good session, the earlier session on the predictive analytics. Yeah, there may be some overlap in the content what happened in the last session and this session, but I will try to make it more interesting and try to see that we learn more of implementation strategies and the real-time challenges what we face in the industry. Let me try to explain that and try to be more practical. Let me start with my presentation. I think let me share my screen. I think you're able to see my screen, right?
Yes, sir. Yes, sir.
Okay, thank you. Thank you. Okay. So today we'll just have an hands-on session on building and predictive analytics. Before going to hands-on session, let me just brief about basically what is predictive analytics. It may be just repeated stuff, but yeah, it's my own orientation. Basically, predictive analytics is like we take the historical data and we use the statistical algorithms or machine learning techniques basically to identify what is the future outcome, what will be the future outcome, right? Basically, it has three components. One is the historical data, that is the foundation what we use, and we use the statistical methods to process this data. And our goal is to forecast the future events or behaviors with reasonable accuracy. I'm not saying exact accuracy, but it is reasonable, right? So basically, we do forecasting in this, and basically, most of the common applications are in business, right? You take all the last year, 10 years sales, and you want to forecast what would the future sale. So, what is the market trend going on, right? How the customer will purchase the next product. All this will happen in the business. In healthcare, basically, we identify the patient risk and disease outbreaks. Like, what is the chance that he may get a heart attack or a diabetic in the next 5 years or 10 years based on his previous habits or food habits or age or whatever it is. There are a lot of parameters to consider. And in financing, we may see like what is his credit scoring, whether we can issue a loan or not, all this, right? We are not just more concerned about the other areas. We just try to focus on the healthcare for today. But these are the use cases generally we use for predictive analytics. And basically, when it comes to predictive analytics, for healthcare, normally what we do is we take the medical records, health surveys, disease and patient registries. Not only this, you may also take the data from the IoT. Nowadays we have smartwatches, right? It stores all your BP, oxygen levels, heartbeat. A lot of parameters are stored, right? How is your sleep pattern, right? So all this will be stored. This is more, it has more lot of data in your smartwatches. So those records, those data can be also taken to predict because that gives more accurate rather than the regular records which are already there in the hospital, right? So based on that historical data, we'll try to predict something like what is the chance that in next 5 years he may get an heart attack or CVD, right? Disease, right? So that is the forecasting basically. It may not be accurate. A lot of factors imply that. And basically, when we talk about predictive models, there are different models we use. Normally, we use regression model, where this is one type of predictive model, where we use linear regression or polynomial or logistic based on the requirement there. And neural network we use for predictive modeling like CNN, multi-layer perceptron, feed forward, GAN, and all these things. For classification, we may use decision trees, random forest, naive Bayes, SVM. For clustering, we may use k-means, hierarchical density-based DB-scan, like something like that. And for time series, we use ARIMA, exponential smoothing. Decision trees, we use CART, chi-square, and ID3 and C4.5. So ensemble is somewhat a better method where we use bagging, boosting, stacking, and random forest. These are the basic predictive models we use, right? These are the techniques we use for that type of model, right? Now, basically, whenever you are implementing a predictive analytics model for healthcare, so there are a series of steps we need to follow. Any machine learning project has the same steps, but slightly may differ from the use case to use case. But these are the general one. The first one is defining the problem. First, we need to define the problem, like saying that what is our goal, like what is the problem, what do we want to do, whether you want to forecast or whether you want to predict that the patient may get a cancer or heart disease or diabetic in the next 5 years or next 10 years or something like that. Then we collect data. So data can be collected from different sources. So data will be available in different formats. It will be available in JSON format, CSV format. So that is a big job for data engineers where data will be coming from multiple sources and they have to collect all the data and see that all the data is aligned as per the algorithm requirement, right? So that is data preparation. That is the next step. So what data engineer will do is he will collect all the data from different sources. See, your healthcare data you'll be having in medical records in your hospital. From there we need to take that will be having a different standard. So normally healthcare data it will use the FHIR standards, FHIR, fast health interoperability, HL7. HL7 is the standard they use. The data will be in a different format like JSON or something like that. That is your medical record. Every time you go to the doctor, take the prescriptions, use the medicine. Again, they treat, they take the test, diagnostic test. All those data will be stored in that format. Suppose you have some data in your smartwatch, like every day, what is your sleeping pattern? So that you can't explain the doctor that sleep is good or bad, but really I want to know how many hours exactly you have a deep sleep or normal sleep. That data, the real data can be obtained only from your smartwatch. So we need to collect data from different sources available and we need to arrange them and see that we prepare that data in a one standard format which can be given directly to the algorithm, right? So your machine learning algorithm will decide what type of format it needs, right? The data scientist will say that, okay, my algorithm takes the data in this format. So the data engineer job is to collect the data and prepare the data. Once the data is prepared, okay.
Sir, can you please share
Just
slide?
sorry, it's not sharing. Just a second. You're able to see my screen?
Yes,
Hello?
sir. Yes, sir. Yes, sir.
Okay, thank you. Yeah, so that is the data collection part where we get data from different sources and we prepare the data. Once the data preparation is done, means we are getting all the data in one format. Then start the exploratory analysis. This is generally called as EDA process, exploratory data analysis. This is the biggest challenge. 80% of the 60% of the work will be done in this because this is the oil for your algorithm. Because the more you explore and identify the patterns and tune the data as right, so then only your model performs better. It is just like garbage in, garbage out. If some null values or some unwanted values are there in the data, so that will entirely affect the algorithm. So in explorer analysis, we'll see the analysis step by step. That we'll do, then we'll select the model. Okay, whether you want to do a time series analysis, you want to use a regression model, that we'll select some model. And once that is done, we'll do the training. Then the model validation is also very important. So I am saying that my model gives the best results. How do you validate? How can you say that this is getting best, giving better results? Then finally we go for implementation. Not only this, there are other challenges I can discuss. For example, nowadays everybody is asking about explainable AI. We'll discuss about that also. Explainable AI means I said that my model is accurately predicting that you will get a cancer after 5 years or you will get a heart disease after 5 years. Then I may ask the system, how did you come to this approach? Means your AI system should be able to explain why you predicted as that you will get a cancer in 5 years. What are the parameters you have taken? What procedure you have followed? How you have arrived to this conclusion? That is very important. Nowadays, everybody is focusing on that rather than the model. Simply model gives that okay, 60% chance or 70% chance or 80% chance. They are more interested to understand how model is taking a decision. They want the detailed steps, right? That is called explainable AI, which is the upcoming topic or the future in AI, right? So we'll discuss that also. But yeah, these are the steps basically, right? Now, first problem definition. So basically, we are trying to predict whether the patient will get a heart stroke in future based on his various attributes. That is the problem definition. And data collection, you can collect data from various sources like EMR, electronic medical record, electronic health record, servers, and you can collect from IoT devices also. This happens in the real time, right? So normally while doing experimentation, we'll take one CSV file and we do it. But in the real time, it is not like that. We'll get data from different sources and the velocity and the volume of data is also huge. You may get thousands, 10,000s of records and 1 lakh of records, millions of records. So you need to predict. So that is a totally different challenge what we'll face in the real-time industry. But next data preparation, we'll as per the specification of the algorithm, so either we'll convert it to CSV or JSON, whatever it is. Mostly they will prefer CSV. So this is what we do in data problem definition, data collection, and data preparation. These three we'll do. Then what we do is summary statistics. So we'll calculate mean, median, mode, standard deviation, and everything. And that is summary statistics. We'll know, okay, what is the mean value, what is the median value. That gives some idea of what is the data. Then we use data visualization techniques like histograms, right? We want to visualize what is the distribution of numerical values. Normally we use box plots to find the outliers, right? How the data is spread. Box plot will give every uh, chart will give a different perspective of the data. If you use box plot, you will know how the data is spread, whether we have any outliers or not. In histogram, we'll know the distribution. In scatter plot, we'll know the relation between two values, if it is x, y. Bar charts, we'll know the compare category value. We can see how many values are there. Heat maps will give the correlation matrix. Like this, every chart, we need to use all the charts and identify, right? Right. We need to, then we do the correlation analysis, how they are correlate. Then we clean the data, like missing values are there, we'll replace with median or mean based on the use case. And feature engineering, we do that EDA part. Okay. Now, so I'm using the heart data set, heart disease data set from Kaggle, which is a standard one. I'm using all these 13 attributes in the data set. One is age, sex, chest pain type. There are 4 values. And resting blood pressure, serum cholesterol, fast bleeding sugar, resting cardiograph results, maximum heart, exercise induced angina, old peak, slope of peak, and number of major vessels, and thal. So these are the various parameters which we have in the CSV file. Okay. Right. Now, let us go to the example like where we'll start our real-time implementation of the code, right? Now, normally you can write or code the machine learning algorithms in different forms. I am using Jupyter Notebook, which is locally I installed Anaconda and I am trying to run Jupyter Notebooks within my local system. If your system doesn't have much power or much capacity, right? You can always use Google Colab. Google Colab is another good tool where you can just, without any infrastructure, you can just log in with your Gmail ID and try to, right, run your programs there. So that is one other platform where you can use Google Colab. Now, coming to this hard prediction, now what we do is we generally use standard libraries like NumPy, where we'll be using using matrices and other things in the code. So that's why we use that NumPy as a standard library. We use pandas to manipulate the data. We use pandas, right? Pandas is a library which helps us to manipulate the data. And matplotlib is for the visualization. Seaborn is also for the visualization, right? Uh, and we use some models like we import linear model or decision tree model or ensemble model based on our requirement. So here I am just using a data frame and reading that hard data set. I am just displaying, these are the 13 attributes we have. 12 are the parameters. The third one is, last one is the target. It is saying 1 or 0. Means whether he will get our disease or no. 0 or 1. This target is the Y value. Now, so if you are, normally what happens is, if you want to do exploratory data analysis, I'm just showing info. Info means it is showing what are the column names, how many non-null values are there. It doesn't have any null values here. It is good. It is a clean data set almost. So it is doing. Normally, most of the times what they do is, they do info. Info means it will show all the attributes and the values. But normally we have to do dist plot, you have to do histogram, you have to do just like what we discussed. We have to do box plot. We have to write a code for all the different charts and we have to visualize the data. So nowadays there is no need for to do all that, right? All those doing dist plots, finding null values, right? Entire EDA, entire exploratory data analysis can be done with a single command. This is the very simplest way you can start working on it. So that is called as wide data profiling. So wide data profiling is a pretty new concept where we can get all the analysis done with a single command, right? I will show you that. Okay, now I am just installing the, because I don't have that package, I am installing that wide data profiling here. Then from Y data profiling, I am using profile report and I am just saying profile report of data frame. Just 3 lines of code will do the entire analysis for you. Instead of writing a code for Python program for dist plot, Python program for a bar chart, for right scatter plot, you are doing all of those, right? So I am trying to eliminate all those just using Y data profiling. So once the Y data profiling is installed, so what I can do is, this is installed. You can see here, you got a beautiful pandas profiling report, right? I will just expand this for your convenience. Let me just expand the window so that, see here, I have just run these 3 lines. It gave me a complete report here, right? So let me just go down. Okay. Overview. See here, overview. Number of variables 14. 13 are the input variables, 14th one is the target variable. So you have a numeric 5 and categorical 9. So we have different types of variables there. So number of observations, we have 303 observations. Missing cells, there are no missing cells. Missing cells percentage, duplicate rows, there is one duplicate row. That is 3%, 0.3%. Total size of memory and average 114. Average record size in memory. Now, see here, for variables, and here you can go, right? You can see here, yeah, let us go down. You can click here also on the tabs, or you can go down. Variables. See here, for this variable, let me just try to expand this. Yeah, for this variable, you see I selected age. It is showing you how many distinct values are there, how many missing, how many infinite, what is the mean, right? What is the minimum, what is the maximum, what is the zeros, right? So you got a graph also here, right? And like that, you can select for all variables, right? So every variable you can see how many distinct values are there and everything, right? If you want more details, see here. For more details, you can see statistics. What is the minimum? What is the fifth percentile? What is the standard deviation? These are all descriptive statistics. You got all these things here, right? Now, if you want to go for histogram, you got the histogram here, right? You got the boss, right? You got the correlations here, right? Heat map, missing values, count. You want to see in the matrix, you can see here. So that is for one variable, right? You can see the common values. So these are the common values. If you want to see some extreme values, you can see here. Everything, right? Everything is done. So you can see when it started, when it ended, what is the duration it took. But yeah, correlations you can see here, right? So yeah, right. So I think we are good on this profiling report, right? So we got all the data what we want almost with just 3 lines of command. Now, once we got this, right, we are good. This is just I made it for checking null values, correlation matrix. That's what already I did it in profiling. So we got all the data and we did it, right? Now, this is also again a histogram to know the values. This is all done by the data framing. Now, so what I am trying to do is I am just trying to use uh, different algorithms and see what is the accuracy. Okay. So first I am trying to use the logistic regression. Okay. I'm trying to use log. So this logistic regression, this is a standard module where you can import the cross validation score, grid search V, CV, and here we are taking the logistic regression. We are passing these hyperparameters, and we are just saying that fit model fit. We are taking this as model 1, and we are importing the confusion matrix, and we are creating the heat map using SNS Seaborn library, and we are calculating the true positive, true negative, false negative, false positive. So, and we are calculating and we are putting the values there so that you get the testing accuracy is 88%. Sensitivity this one, specificity and precision. This is what we got the confusion matrix here, and we got the accuracy of 88, right? So that is one. So here we are calculating. So you can see that recall is 0.82 precision, right? And it is 0.93 for this and this. And we got an accuracy of 88%. So here this will give classification report will give you the precision recall F1 score. Support means number of instances which are there for this, means number of records which are valid for this, means how many records are involved for this. That is what support. So this is a simple linear regression for predicting, right? Now we are using a decision tree. So this we got 88%. Okay, 88% is for linear regression. Now we take a decision tree. So in decision tree, we use decision tree classifier where we say that we'll fix some maximum depth, otherwise we'll get a problem. So we made it as a depth as 5, and we take the criteria as entropy. Based on the entropy, we'll take a decision, right? I don't think we need to explain about what is entropy and all. And here we are taking that CV as a such value as 10, cross validation count as 10, and scoring is accuracy. Then we take this model, will fit, will predict. So again, Here in the decision tree model, we again calculate the same and we get the 96 accuracy, right? But there is maybe some issue here, but we got accuracy of 96%. Okay. And yeah, this is the uh, matrix, confusion matrix for that. Then I try to use the random forest classifier here, right? So this is, first one is 88, this is 96%, and this is the random forest classifier. Okay, in random classifier, we take again the same values as entropy and depth and all these things, and we calculate here, we get this confusion matrix. Here we got the accuracy of 86%. Okay, this is 86%, 87% accuracy here. Right. Then I try to use, say I'm using different models for predicting. Right. So I use support vector. I just want to know which one will give you the better accuracy. So this is support vector mission I am using. I'm trying to fit the model and trying to find out. This got an accuracy of 85%. This 86% here. Okay. Now it's got 87% here accuracy. Now, so what I'm doing is once I find out which model is better, so if it is 86 or 88, 96 or whatever it is, right, don't just assume that this accuracy is correct. There may be some imbalance, there may be overfitting, there may be some problems. We'll identify that. But so I'm just giving some input values, random values, and I'm just predicting the model. I'm using model 4. Model 4 means I think I am using here model 4, this one. I'm using support vector mission as a model. So I am passing the values to the support vector mission and I am trying to predict. So if I am saying it is 1, the patient seems to have heart disease, else normal. So here I passed some random values here and I am testing it. So once I test, it is saying that patients to be have a heart disease, right? So I tested with some other values. Again, it is giving heart disease, right? So both positive and negative cases should work perfectly. That we have to test for different models, right? So finally, I try to use the XGBoost also. This is another method what we discussed in predictive models. This is the ensemble method. So what I did is I tried to install XGBoost and use that algorithm and try to run that classifier where, see here, I after running this algorithm I got a testing accuracy of 1. This training accuracy of 1 means on the trained data set, you know that already we have discussed about the train test split, this one, right? So we are taking here 70-30%. Right? 70% for the train, 30% for the test. 70-30, 80-20, 75-25, depends, right? It's not a standard that we have to use only 80-20, but most of the time they use 70-30. The training accuracy is 1, and if you go for test accuracy, it is 0.81, means 81%, right? So some challenge is there. It's somewhere there is some overfitting. So what we do is normally to see that how we got the training accuracy, right? So you can generally we use a receiver operating characteristics curve, ROC curve. So it is very simple to draw an ROC curve. So you can import ROC curve display here in the module. Here I imported the ROC curve display and then yeah, here I imported it from a scalar matrix, right? So here I gave from predictions, y prediction, y test, plot chance level true. So here you can see that the classifier AUC, area under curve is 0.81, this one, right? And the chance level is, normally it is 0.5%. This is the your false positive rate, right? So what we do is, because we are not actually matching that, because it is 1 and this is 0.8, 81%, this is 100%. There is a lot of deviation there. So what I try to do is I try to do some tuning here. Okay, so I try to do some, let me go down. Yeah. So what I do try to do is I do some tuning. Tuning means what I'm doing is I am slightly changing the parameter gamma is equal to 3, learning rate as 0.05, and again I will tune the model. Right. Once I tune the model and again try to fit the model. Now, after fitting again, you can see that I tested the training accuracy and test accuracy. Now, the training accuracy is 0.91 and the test accuracy is 0.86, almost near. Right. So again, I plotted the ROC curve, right, where it is 0.86 and the training accuracy is 0.91. So this is how we try to find out which model gives the better accuracy. Normally, your AUC, ROC are very important to evaluate your model, right? So this is how we do the prediction model. We can use different models. We have to try out different models and see which models performs better for the specific type of data. And based on that model, we try to use that model. Okay, right. So this is about the prediction model. Now, so in the real time, there are a lot of challenges which happen. Let me try to discuss on that. Now, today you implemented, for example, you can take this one. Yeah, this one. If I take an example of XGBoost, okay, right. Now, the biggest challenge in machine learning is tracking. What is tracking? Tracking means, for example, I will tell you a simple example. Today, I told you that, okay, you try to experiment XGBoost algorithm with a different learning rates, with different data, training data set. For example, I want to test my XGBoost model with different combinations. For example, case one, I want to test with a data set of 70-30, right? That is one. I want to test the data set with combination of 80-20. I want to set the data test with 75-25. Like test train test split, I want to use different combinations. That is one case. Next, another one. While fine tuning, right? While fine tuning, I want to use different learning rates. I want to use learning rate of 0.05. I want to use learning rate of 0.06. I want to use learning rate of zero point 0.7. Like this, I want to use different gamma values. Like this, if you assume that there are three parameters, like the training data set split, the learning rate, the gamma, three. In each, if you try with 110 combinations, like means the test data set 10 combinations means 70-30, 75-35, 80-20, 85-15, like that, some 10 combinations. Gamma, you may have values from 1 to 5 or whatever it is. Learning rate, you want to start with 0.01 to 0.09, right? You have 10, 10, 10. So if you combine again all these one case with the other, so it will be 10 to the power 3, 1000 combinations you get. So in 1000 combinations, you also want to find out what is the accuracy for each combination. Right? This is a huge task. It is very difficult for you to write programs with the different combinations and try the accuracy. And you want to store the model. You want to store what parameters you want to store, right? Tracking all these combinations and all your R&D, it is a huge task, right? It is very difficult to solve all these problems, right? So recently, industry has come up with a wonderful tool which is called as ML flow. We'll discuss that, but let me just go back to the challenges what we have. Normally, what happens is the poor quality data. We don't have data. We have a lot of missing values that will affect a lot. Overfitting is also a big problem. You training, if it fits more for training data. Model interpretability, that is also a problem, right? You should understand the model. Selection bias, the training data what you select should not be biased. And there are some unforeseen changes in future which can make your model inaccurate, right? Right. Now, let us try to go with ML flow now. First, let us see what is ML flow. Let me just directly open a website, ML flow. So basically, ML flow is used to track your entire experiments, what you do in your machine learning. It can store your, see, normally when a learning model is deployed in industry, what they do is they will store all the values. Okay, what data set has been used for this experiment, how it has been split, what parameters we are storing. Finally, what model has been identified, means which is the final model. What model has been used for predicting. All these records has to be stored. That is very important in the industry because if some model misbehaves or you get the wrong value, they will come and ask you, how did you test it? What was the data set split? And what is the parameters you used? Which algorithm? What is the learning rate? What is the gamma rate? All these things they will ask you. So it will be very difficult for you to track all this and store all these things. So that's why. So this ML flow will help you a lot. So it is very simple installation. So what I will do is I will show you how to install and run. So normally, if you want to install in your local machine, it is just a simple command. You can start with, I think your screen is visible for you, right? I will just make a screen bigger. Okay. So to install, just you have to use pip install ML flow. Okay. So once you install ML flow, so basically you have to create one environment, right? So normally we use Conda. First you have to create one folder. In that folder, what you have to do is you have to create an environment. So you can see here there is an environment already created, right? In this ML flow experiments is one folder. In that, so what I have to do is I have to create Conda create hyphen name. I have already created. I am just showing for your convenience, and you can give any name, right? You can give ML flow and you should give what Python version because see uh, what Python version you will be using, right? See, in industry, we'll be working on tens of projects, right? Different projects. Every project will have a different dependency. One project may need Python 2.7, one other project may need Python 3.12, one project may need 3.10. So different projects need different Python versions. So that's why definitely we have to create a separate environments for each project so that all the dependencies of that project will be there in that project only, right? And the Python version will be applicable only for that project. So it's very important. Once you create an environment, right? So what you can do is you can activate the environment. So I have already created the environment. You can see here now it is showing you base here. It is showing you base. Now I will activate the environment called ML flow because all the dependencies are stored in that environment. So once I activate, you can see here on the left side, you got ML flow. Means right now I am in the ML flow environment where your ML flow is already installed. Right. Now, if you want to run the ML flow, right, think it is ML flow UI. Okay. Yeah, ML flow UI. Think this should work. Okay, let me find out. Let me try to install ML flow. Yeah, it is installing. I think it was not there earlier. That's why you are getting some errors here. But anyhow, I think there is another command here which is already there. But anyhow, let me check. Okay, now ML flow is installed. Now, if I want to start ML flow UI, right? So it will start a server in your local machine, right? Which will be by default running it port number 5000. Now I can see the ML flow server. I'll just go here. I will write localhost 5000. See here, you got, I will delete whatever it is there earlier. So I will, let me try to delete that. Okay, now, okay, see here, you don't have any project experiments here. Default experiment is there that we can't delete. So this is the ML flow server, which will track everything what happened in the your machine learning algorithms. So this is the experiments what we do. Now, this is the experiments and these are the models, right? Some model is already there. Let me try to delete that also, right? So this model, yeah, this version 1 is there. I will try to delete that so that we have a clean slate. So this is experiment. Now, I think you got the ML Flow UI screen where now let us go to the code. Now, let me try to this, let me keep it here like this. Let me try to explain. Now, for this ML Flow, what I am doing is I am importing the Pandas library. The machine learning algorithm code what we write, it is same, right? I am just importing ML Flow. I am importing ML Flow models in for signature. That is another model which we use. Now, I am trying to write a simple iris data set. Iris data set is a flower data set where we use sepal length, sepal width, and all these things and identify the flower. So that's what we do in that. So that's why I'm taking that very simple example so that you can understand. Now, so what we have to do in this program is this is a normal program which is written for just for now. You don't worry about the extra lines, but I'm just writing an linear model, right? I'm taking now. So what we do is we already know that the ML server, ML flow server is running in some port number. So what I have to do is first I have to set the tracking server. Means I want to say that, okay, whatever you want to track, please track in that server. So I am writing ML flow set tracking URI 127.0.0.1, or you can put localhost also. If it is a public server, you have to put the public IP there or the domain name here. Okay. So 5000. Now, this is a tracking server UI. You set up the URL. Then you have to set up the experiment. Say that mlflow.experiment, iris model. I'm just saying iris model. Okay. Then, so you are just taking the load iris data set. This is common logic. You are loading the iris data set. You are doing the split and training data set. Then you are using the params. Means what solver you are using for that hyperparameters. How many iterations you have to do. It is a multi-class or not. What is the random state? That you are sending the params. This is the model hyperparameters. Then what you are doing, you are learning the logistic regression using sending the params. You are writing lr.fit, right? Linear regression dot fit, and you are predicting, and you are calculating the accuracy score. Right? These are all normal what we write as a machine learning algorithm. Now here what we have to do is we have to write with mlflow dot start run, right? Then you have to write mlflow dot log underscore params is the method for which you have to suppose you want to store these parameters, right? I want to store all these 4 parameters. So that's why I'm passing these params. Log underscore params, I am sending the params. Now you want to store some metrics. So I am saying mlflow log underscore metric accuracy. I am sending the string and I am sending the accuracy value. Now what system will do is whenever the machine learning algorithm runs, it will take these parameters, it will store, and it will also store the accuracy. Then I am setting some tags, training info, basic LR model for iris data. Then I am inferring the signature. I am predicting it, right? This is the signature for the model. Then I am just running this model, and then after learning this model, a model will be created. Then I am loading the model. Once you run this model, you can just write mlflow.py function.load model, and you can use model info.model.uri. It will create a URL automatically for the model. So you can load the model like this, and you can do the predictions. and you can store the feature names. You can get the feature names. You get the result in the data frame, and you say that result actual class and result predictive class, and you are just storing the fourth one. You are just showing the 0 to 4 values in the result. This is the Python program we have written, and now I want to just run this program, right? So to run this program, just it is Python, I think trackml.py, that is the file name, trackml.py. Just move this one, okay? This one. If I run this program, you can see here it is running, right? So it will try to run and create an experiment and also store the params and also create a model. Okay. Now you got some error. Okay. Let me do one thing. It is coming, some error is coming in line 13. Let me check that. Yeah, I think I deleted that one experiment. So let me do one thing. I'll write updated model. Okay. And let me try again here. Because earlier I ran that. Now I am trying to run, just changing the name and trying to run. You can see that it is running now successfully. Right. Now it ran. Now you see here. Right now in experiments we don't have anything. Right? But it has run. Now I want to just refresh the browser. See here, you got Iris updated model. Right? Here, you click on that. You can see a run name. Right? Some dynamic name will come here. You can see that 18 seconds ago. Right? You can see that model. The model is tracking Iris model version 1. Version will also be given automatically. You can see how much time it has taken for running that. So these are all very important in the industry. When I run any machine learning algorithm, I should know what time it has taken. Normally, what people do is they write some program to calculate the time, end time, start time. All these things are not necessary. So you can directly use this MLflow tool so that you'll get the duration and you get the run name. Now, so I want to see these are the models. You will get all the models. The every experiment you create here, you will get the experiment names here. For every experiment, you will get the run names here. You can search when the time is created, whether it is active or not. A lot of things we can do. Okay. Now I click on this run name. See here, overview. So this name is dynamically created. Don't worry about that. Now you can see here this overview of this run. It was created at this time, created by my name, my client name or a company name. Experiment ID will be automatically generated. Status is finished. If it is not finished, it will show some error there. Run ID, this is dynamically given. Duration 1.95 seconds. Dataset used. You can write this also so that it will store what dataset you have used. There are a lot of logics we can implement here, but I have not implemented that. See, I have given some tag, right? Training info basic LR model for edge data. What is the source? Trackml.py. What logged models sklearn? Right? Registered models is tracking iris model. Now see here, parameters. Random state, solver, max iteration, multiclass. What parameters, hyperparameters I have given? It has already stored here. Now see here, metrics. It has stored the accuracy. Accuracy is 1. If you click on accuracy, it will show the diagram. Right? What is the accuracy? What is the minimum? What is the maximum? Right? This is 1. You can see. Okay, that is 1. Now, model metrics. You can see here model metrics. That is accuracy. We are using only accuracy. You can use n number of metrics, whatever you want. You want to do confusion matrix, whatever metrics we have, everything can be stored here. System metrics, nothing is there. See here, artifacts. What do you mean by artifact? I have created one logistic model, one logistic regression model. Okay. And I have deployed that model and I have run that model. It has been deployed, right? So whenever you deploy some model, that should be stored in the model registry, right? That we generally call as an artifact. So here, if you see artifact, you can see the iris model. You can see what is the ML model, right? What is the ML file I used? What is the input example? This is the model PKL file, right? Python environment requirements, right? All these are automatically stored. This is called artifact. So which model has been deployed? All the models will be stored here. See here, you have this one. This is the URL, right? If I want to do any prediction, right? I will just drag this one here. If I want to do any prediction, see here automatically it is saying validate the model before deployment. So directly it is showing you import validating serving input and it is using this URI. See here, it gave you a code, predict on pandas data frame, right? So it has given the code for prediction. You can copy and you can run in Python, it will predict, right? You want to predict something on the Spark data frame, you can use it. So these are two different methods. So you can pandas data frame, you use this one, right? For Spark, you use this one, right? You can use this for predicting. So means right now this model is deployed. So if you go for model registry, right here, earlier we saw that. Let me go back here. So in models, right, we didn't find anything. This is experiment. Now you go to models, you can see here one model is registered. The model name is tracking iris model, version is 1. Okay. Now, if you click on this, you will get to the same point, version 1. This is the version 1. If you have 10 versions, it will give all the versions with time, right? So you can click on one version, then you can see what are the inputs, what are the outputs, right? So if you give some inputs and outputs, it will show you what type of input you have given, right? What is required, what type of input is required, it is asking you what is type of output, right? So if you write any tags, it will show you the tags. If you write any description, it will show you the description. This is a model which is deployed already. So this model will be having an URI, right? So that's what we have seen earlier, right? You go to experiments, if you go here, if you click on this, if you go to artifacts, it is showing you some, right, this one. I can use this URI, the endpoint, and directly try to predict a logistic regression model by passing the inputs. That's what they have given here also. Simply you can write, copy this in your Python program because it is using this artifact. You load that one and you just predict. So this data, we have to send it. We have to send this data through some array so that this will automatically go to that model. It will predict and it will give the answer. Okay. So this is about ML flow. Okay. Which is mainly, it has a lot of features, right? So ML flow is again a very big ocean, right? So it will take years to learn or months to learn, and if you want to learn every feature, right? So and see the depth of it, it will take a lot of time. But I try to just introduce you how can you track the machine learning models. Normally, how we track machine learning models in the industry, right? Which will be helpful for you while you are doing some R&D. So it will be very helpful for you to manage all these things easily instead of writing your own code or writing somewhere in the WordPad or somewhere noting down the accuracies and all these things manually you are doing. Instead of that, you can do this so that it will be saving your time and you can have a perfect documentation for your models for research papers, right? You can, yeah, you can see what data is given, what accuracy you got. All this you can really track it, right? So coming to this, there are a lot of how to deploy and all these things, right? So this is a very big subject again about ML flow. Okay, that is ML flow. Now let me just go back to, yeah, here. So who will use ML flow? So there are different people who are using ML flow. One is the data governance officer. Data governance officer is the highest position. The person will use the ML flow for all the things. He will use for data preparation, EDA, feature engineering, model training, model validation, deployment, monitoring. You can do all these jobs in ML flow. Okay. Coming to data engineer, I told you that data engineer is a job which they will just prepare the data. They don't do any analysis. They will prepare the data as per the requirement. Collecting data from different sources, right? And preparing the data. That is the job of the data engineer. That is the first basic role which starts in when you go for a data scientist. The basic role in data engineering is the data engineer. That is the first role. People start with that role. They try to connect with Oracle. They can try to connect with Snowflake. Different sources they will try to connect, and they will get the data from different sources and they will prepare it. Right. Now, coming to data scientist. Data scientist will use this for EDA, feature engineering, model training, model validation, right? You know what is model training, right? You know what is model validation also we do, and deployment, we deploy the model. Now, the ML engineer, machine learning engineer will only focus on validation, deployment and monitoring. So he will validate, he will deploy, and he will continuously monitor the model whether it is performing right or wrong. If something is going wrong, it is not perfectly predicting, again, it will go here. They will do the feature engineering. They will again train the model. They will validate the model. They will deploy and they will see. So this is a continuous process, right? It is not that today I build a model, which will work for years. No, because the data is changing very dynamically. Your model may work for 1 month or 2 months or 3 months because you are getting new data, right? So your model works well only when you have a lot of data. So you have historical data of only 6 months. Now after 3 months, you have historical data of 9 months. If you get 9 months data, your model can predict more better. So this fine tuning, model validation, model training will happen on regular basis. Not every day, maybe month or 2 months once or 3 months once or 6 months once. It all depends upon the use case and how data is flowing into your environment, right? So that's what happens. So business stakeholder, normally business people will always, they will not generally validate the model, but they will always see whether it is giving the perfect prediction or not. So this is what happens in the ML flow. Now, what are the real-time challenges in healthcare? The first challenge is data security and privacy, right? So because the health information is very sensitive, we should be very careful about our data, right? So there are some HIPAA standards, health interoperability standards. So you have to follow that regulations. Your data should not be, yeah, you should protect the privacy, right? And you are a healthcare company and you are giving this data to some other company for analyzing. You should be very careful that that company doesn't breach your healthcare data, right? There are a lot of challenges here. That is one of the challenge. Accuracy and reliability is again a challenge. So one misdiagnosis will create a lot of problem. We should be carefully monitoring uh, on daily basis and see that the model is working perfectly, right? And providers must balance the acceptance. Means the other person should be able to accept your model accuracy because, right, that is very important again. Okay. Now, I discussed about explainable model, right? So today what is happening, you can see on the top. Today what is happening is you are training the data, it is learning. Finally, you got a learned function. Then this learned function will say you whether this is a cat or what is the probability that this is a cat. You will get the output. What you will usually do it? Why did you do that? I have a lot of questions. Why did you do that? Why not something else? When do you succeed? When do you fail? When I can trust you? How do I correct an error? All these are my challenges because I am getting some prediction as an output. I don't know how I got to that answer, right? People may say that, okay, for this question, this is the answer. But next question is, I will ask you, how did you arrive for that solution? Till now, in AI, the explainable AI model didn't come. Recently, everybody is discussing about explainable AI because they want to really understand how the model has taken the decision because it may take some wrong decision also. if I know how it has, what steps it has taken and how it has followed, if there is any chance, I can correct it. If I don't know, if it is a black box, if I give some question, it gives answer. In the black box, we don't know anything what is happening. So that people will not accept. People will ask, okay, I will say, okay, this patient will get a heart attack in 5 years. Then doctor will ask, how did you predict that? Please give me an answer. So whatever the machine learning model I have developed, I should be able to give the answer. That is called explainable model. Your model should be able to explain it. So this is tomorrow. Tomorrow is, yeah, present or tomorrow, whatever it is. You are training, you are getting some new process. You should develop some explainable model. And this is a cat. You are saying this is a cat with probability 93 here, but here you are saying this is a cat, but why you are saying this is a cat? Because it has fur, it has whiskers, it has claws, it has this feature. You are saying that because of these features, I identified this as a cat. That's what you are trying to explain. Here, user knows, I understand why, I understand, I know. Here it knows you know everything because you have defined an explainable model where you are explaining why did I come to this answer, right? So you are trying to explain, right? I got to this answer because of this. So you are trying to explain that. That is the future of explainable AI. Okay. Uh, yeah, I think I am done with my presentation. Think I tried my best to explain whatever I do on daily basis, right? I think it is 8:50 almost. So I leave 10 minutes to the participants if they have any queries.
Thank you, sir. Dear participants, if you have any queries, please post it in the chat box. Sir will respond.
Thank you, Priyanka. Yeah, sure, I can share the data and code, not an issue. It is not my private property. It's a public one. Because when we work with clients, we can't share that client data, but that's why I have taken the public data only, right? So it's again an oh, participants are already exhausted for today. No questions asked means
Okay, sir. Sir, we are truly grateful to you, sir, for contributing significantly to this FDP through your valuable insights and engaging presentation, sir. Thank you so much, sir.
thank you. Welcome. Yeah.
Dear participants, we have now come out at the end of the fourth day of this FDP. I trust this session is a fruitful one. We look forward to continue this enriching learning journey tomorrow at 6 p.m. sharp. Thank you all.